Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
What is up, guys, and welcome to the very first section in our Swift 4 Language Basics tutorial. Hopefully you have seen the list of learning objectives, so know that the first few sections are going to be dealing with variables. These are the topics we'll be covering. I'll get back to this in a second. Then we'll move on to collection types. After that, we can talk about control flow, then functions, and finally finish up with structures such as classes or structs. If you weren't already aware, I am right now in the Swift 4 playground, or I guess this is Xcode's playground. So when you start up a new session of Xcode, there are three options. One is to start a new project, one is to start a new playground, and then one is to check out an existing project. Well, you want to select the playground and it'll bring up a nice blank screen like this. Typically it has a line of code that outputs hello playground, but I just deleted that here and just have some comments. Now comments will be ignored by the compiler, which is why I have them typed out here. But you guys don't have to type these out. This is just basically a list of the topics we're going to be covering. So with our variable discussion, we're going to divide this into 4 sections. The first one will deal with a basic intro into the concept of variables. We'll explore some Swift 4 specific syntax as well as the basic types that we'll be using in everyday coding. After this, we can cover a very special variable type called the optional variable type. And this basically allows variables to take on the value of nil or have no value associated with them. Maybe a weird concept to you if you haven't experienced the idea of a variable having a null value, but we'll get to that in due time. After that, we can cover some basic operations that we can perform on variables by taking a look at the basic operators and a few examples. And finally, we'll wrap up our discussion on variables by talking about tuples, which are essentially a way to associate multiple values with a single variable, but are not quite the same as stuff like collection types, such as arrays. Now, as this is the first language basics section, I should preface things by saying that we don't have a ton of time to talk about a lot of stuff. We have a lot of material to cover, so I will be going through things a little more quickly than personally I would like. If I had the choice, I would drag this out for hours, but we are trying to keep things compact. So if you find things a little too fast, then feel free to watch videos either A, a little more slowly, or B, go back and watch the same video multiple times until you really understand the concepts we covered. It's important that you do, because each section will be building on the previous section's material. As well, because the playground is such a versatile tool, it's always a good idea to, at the end of each section, review the code that we wrote and then try some examples off your own, but obviously change up values and stuff like that. It's easy to do in Playground, and I think personally the best way to learn coding is to practice as much as you can, particularly when we come to a problem, try to solve it yourself. If you really get stuck, then watch the solution we'll provide. Okay, so let's jump right into our discussion on variables. So what exactly are variables? If you're not familiar with this concept, variables are essentially a way to store a certain value and associate it with a particular name. We can then call upon that name to either retrieve the variable's value, or we can assign a new value to that variable provided they're of the same type, and I'll get to types in just a second here. Variables are a great way to keep track of values as they change throughout the code, and it's always encouraged where possible to use variables instead of the literal values such as the number 2 or 3 or whatever. Better to assign a value to that variable and then use the variable name. Now, there are 4 main parts to a variable. I guess 5 if you include the access modifier, but I don't think we'll get into that. It's a slightly more complex topic. So 4 components to the variables for now. One is either the var or the let declaration. So it looks like this, variable, or let for a constant, okay? That tells us whether or not we're dealing with a variable whose value can change later on, or a constant whose value cannot change throughout the code. So once we assign a value to a constant, that's it, we cannot change that. The second part to the variable is the name that we're going to assign. And actually, I'm going to write these out in a comment. So we have var/let, again, variable for a variable, and let's for a constant. Then we'll have the name, okay? Then we have the colon here, Although this is not strictly a necessary step, always a good idea to do this where possible, we have a variable type after the name. Okay, so the type is going to be used to restrict the kinds of variables or values that the variable or constant can take on, as well as, if you want to get technical, the amount of space in memory that variable is going to take up, but we're not going to worry about memory space right now. Okay, after the type comes the equal sign if we are assigning a value, and then the actual value that variable is going to take on. Now there's actually alternative ways we can go about this process. This is called declaration and initialization. Specifically, the declaration is giving the name and the type to the variable. The initialization is giving it a specific value. So we could do something like this. For convenience sake, I'll be using constants as much as possible, but if I need those values to change, I'll have to switch to a variable. So we could have something like this, a name and a type, all right? And this will basically assign a default value to the variable based on what type we chose. Alternatively, we can do something like this, let name, and we can actually just give it a value right away, and the compiler will infer what type of variable what type of value this variable is going to take on based on the value assigned. So for example, if we change the value with 0, then the compiler would automatically think that name is going to be an integer, which is a type that represents whole numbers. Now, where possible, it's always better to do this because you're providing the compiler with as much information as possible, which is always the best case scenario. You're giving it not just a name, but the specific type, so there are no type errors later on, as well as a definite value that you want your variable to take on. So try and do this where possible, but if you just assign a type and then a value later on, that's fine. You can also ignore the type and let the compiler infer it. So now let's quickly talk about the different types of variables that you'll see. So you can have pretty much any type you want, and if the type doesn't already exist, you can create your own custom type through the use of classes, structures, and enumerations. But that's a different topic for a little later on in the language basics. For now, I'll just talk about the types that we commonly use, starting with the primitive types. So these are integers and their variations. We can have doubles or floats. These are used, so integers are whole numbers. Can be positive or negative or 0, but cannot represent decimals. Doubles or floats are used for decimal places. Doubles are the default, but we will end up using floats a lot also. After the numerical types come the Boolean type. So the Booleans are basically true or false values. They can either have the value of true or they can have the value of false. So very useful for true-false situations. After this, we'll have the character type, or char, and this is basically just a single-digit character. So it could be a number, letter, or symbol, and is represented by a Unicode. We don't use characters so much because we have another type which is a lot more powerful, and that is the string. So strings are essentially a string or a list of characters and can be used to represent words, sentences, or paragraphs of text if we want. As the length is much greater than that of characters, as well as the fact that they're a lot more powerful than the basic characters, I typically stick to using strings rather than characters unless I know I only ever need to access one particular character at a time. So just going to make some quick modifications here, characters and strings, there we go. And these are integers or ints. So now let's solidify what kinds of values these types can have by taking a look at some specific examples. So a nice place where we might use integers is again going to be somewhere we'll use whole numbers, so we could do something like the number of lives that a video game character could have. Now, like I said, I'm going to make these constants unless I know the value is going to change, so let's just use constants as much as possible and then change them to variables when we know those values need to change. So we could have something like number of lives, okay? We can set this to be of type int or capital INT, and then we can set that equal to, let's say we have 3 lives total. Now again, this value can't change once assigned because it's a constant, but if I change that to VAR, we absolutely can change that. Now note the naming convention. First of all, it is a noun. This is a specific number of lives rather than an action such as change lives or hold lives or something like this. Also note the camel case convention, where we start with the first word uncapitalized, then capitalize each successive word. You can honestly follow any naming convention you want, but this is pretty standard and encouraged. Now, because this is a whole number, we could actually leave out the type altogether, and the compiler would know that this is an integer. But like I said, we want to try to encourage the use of the name, type, and value all at once, just to avoid any conflict issues later on. Also, one other thing that I'll point out, when I started typing in int, note that there were a bunch of other options that came up. So 8, 16, 32, 64, as well as if we scroll down, and it's going to be way at the bottom, there's going to be some unsigned integers that you can choose from, so uints as well. So these are just variations on the int, the numbers that stand beside each of the words. So we load an int. The numbers here represent the number of bits, so as we get larger, they can represent higher and higher values. And then the uints are positive whole numbers only, so they can't take in negative numbers. For the most part, however, we will use the very standard int, unless specific functions call for other types, such as the random number generator needs an unsigned integer, but we'll explain more on that once we actually use those types. Okay, so those are integers. Now, somewhere we might use doubles or floats is again going to be a place where we would need a decimal number. So the use of doubles and floats is pretty much exactly the same. It's just that some functions take in floats and some functions take in doubles. And so it's usually very clear which of the double or float we are going to be needing. But know that if we entered a decimal number without a type, the compiler thinks of it as a double automatically. So we could have something like progress, might be a good place to use a double or a float, be a double. And we're going to set this to 0.8 or something like 80%. So we could assume progress of 0 is 0% and progress of 1 is 100%. So 0.8 would be 80%. Now as for Booleans, probably the most simple of them all because they can only hold one of two values. Again, these are going to be either true or false values. So something like is door open. And we could set this to a Boolean, or bool is the one we want. Okay, and we could set this equal to false. So door is not open. Boolean names are very often questions, so that we can easily determine, okay, it's going to have a true or false value based on the answer to that question at that point in time. Okay, characters. Let's just call this one something like space character. Okay, and this is just going to be a character. All right, and we can set this equal to, we'll open up the quotations here, something like just a simple space. That's actually all we really need. A blank space like this is actually considered a character, as there is a specific Unicode to represent that. Now characters do have to go between these quotations here, and again can only be 1 unit in length. So as soon as I start assigning more than 1 unit in length, you see I get this error immediately popping up here. Okay, now last but not least, we are going to have our strings. So we could have something like let name, and this is going to be a string, equals something like, and note how the syntax is similar to that of characters, but again there's no particular length restriction. I'll just enter in my own name and that works right there. Now as I said earlier, these are all constants, so we can only access the values. We can think of them as being read-only. So for example, let's say I wanted my is door open value. Well, luckily for us, Playground's easy to use, so we can just simply print out is door open, and this value should appear right there. We could then retrieve this value and store it within a new variable. So we could say something like let is the door open. I know these are very similar wordings and essentially are going to accomplish the same task, but now is the door open is taking on the value of is door open at this point in time, so it would be false. Let's actually change that to a variable so that I can later on change its value by saying something like is the door open equals true. And now is the door open's value is true, as you should see pop up here in a second, but is door open's value is still false, okay, because we haven't changed it at all. We've only taken its value and put it in here. Now there are restrictions as far as assigning new values go, and that is obviously one restriction, the fact that we cannot reassign a constant's values, and the other restriction is that we have to stick to the same type. So for example, if I had something like current progress, okay, and I want this to be an int, well, I cannot assign it directly the value of progress, which is a double. This is going to cause me issues. As you can see right here, it says that current progress is an int and progress is a double, and it really doesn't like that. So we need to stick to the same types. If I change this to a double, however, that would be fine. If I change progress's type to an int, still not fine because that is a decimal number. However, there is a way around this, and this is to use the simple conversion. Now, converting between types in Swift 4 is extremely easy compared to a lot of other languages. We simply put the name of the type we want and then the value within brackets, and as long as that conversion actually can be performed, it will be. So for example, let's say I wanted the string representation of progress, so I could call this something like progress as string, and I'm just going to set this equal to the string form of progress. Okay, this is a conversion that can be performed. It's easy to go from numerical to string, from numbers to the string representation simply by using this conversion. However, something we couldn't do is to say something like let name as double be the double form of name, as that doesn't work. We obviously can't convert this into a number, as that really wouldn't make too much sense. So you get this value of nil because the conversion cannot be performed. So that's pretty much all of the basics topics that I wanted to cover. If I missed any of the basic stuff, as I said, once we need to deal with that, once we start building apps and stuff, I will absolutely introduce those concepts to you. Otherwise, we'll just have a really quick recap and we'll move on to the next section, which will deal with optional variables. So variables are essentially a way to associate a particular value with a name. We retrieve that value by calling upon the name, and if we're dealing with a variable and not a constant, we can also use that name equals and then a new value to reassign it. Now there are 4 main components, 5 including the access control, but we're not going to worry about that. The 4 components are the variable or constant, the name of the variable or constant, the type, and then the value that it's going to take on. There are these 6 main types that we deal with, although there are variations within each of the types. Okay, these are called the primitive types, and strings are not primitives because we can perform other operations on them. And actually, just as a quick example, let's say, for example, I wanted the length of this string. Okay, I could actually just call on name, which is the name of my string, dot length, or I think actually it's called count, okay? And this will return the number of characters within this string, which should be 6, okay? And just wait for that to be pulled up there. Okay, it's going to take a little while to run. Oh, there we go. 6 being popped up there. So, and this is something we can do on strings, but not necessarily the others. As strings are, like I said, a lot more powerful, there's a lot more operations we can perform. Okay, so we've seen some of the values that these types can take on. Ints are whole numbers, doubles and floats are decimals, booleans are true and false, characters are any single-digit character, and then strings are basically any kind of characters that we put between these 2 quotes here. Now we can retrieve a particular variable's value and store it within another like this using the simple equals assignment operator. So we can do this with actual variable values or with literal values like this, as we see down here. We can convert between a lot of the types, but there are obviously some restrictions. So for example, we can't do this because obviously we can't go from something like this to a number, but we can do vice versa. We can go from a number to a string. So just to leave off, what I would encourage you to do is play around with variables a bit more, try creating some of your own, and try to cover all of the types here to see what different values they can and cannot hold. Playground's an excellent tool for that, as it outputs a value immediately just by typing the name of your particular variable. As well, check out the conversions and see which you can and can't perform. The logic behind them actually makes a lot of sense. Like I said, this couldn't be a number, it doesn't really make sense. Just like it wouldn't really make much sense to go from false to a number. I know in some languages, false represents the number 0 and a true represents the number 1. Not necessarily the case in Swift 4, however. So play around with that a little bit, and we'll be right back to talk about optional variables. Hi guys, in the previous section, which was our very first, we gave a basic intro into the concept of variables, as well as explored some Swift 4 specific variable and constant syntax. We also covered some of the basic and commonly used types, as well as how to convert between those types. So hopefully you played around with this a little bit and kind of created some variables of your own, reassigned the values, and took a look at which conversions we can and can't perform. So this is actually all the code we wrote in the previous section. It falls between this intro with the stars and this optionals with the stars, as our new section now is going to deal with optional variables. Now, before we talk about optional variables themselves, I have to introduce the concept of a nil value. So nil is often referred to as null in other languages and essentially means a no value variable. So for example, name is a double, which is the variable that we try to convert from this string to a double. And that conversion obviously can't be performed, so we return the value of nil, which means it's storing no value in here. Now this means this variable has no value associated with it whatsoever, so if we try to retrieve that value or any properties associated with it, we're going to get a fatal error which causes the app to crash. Now, the main difference between a variable having a value and a nil value is that we can never access that particular nil value. We can check to see if a variable is nil without the app crashing, but we can't try to use that nil value. Now, if assigning a variable the value of nil can cause the app to crash, why bother using a nil value at any point in time? Well, sometimes some variables need to be nil. Okay, there are points in time in our programs where it just makes sense for an item to not have a particular value. So for example, consider this case. We have an inventory of items, okay, and we're trying to retrieve the very first item in that inventory. So we could call inventory.first and it's just going to get the first item. But what if that inventory is usually full but suddenly becomes empty? So we drop everything from the inventory and now we still want to retrieve the first item. Well, if we try to retrieve the first item doesn't exist. So that's where we should store a nil value because it doesn't make sense to retrieve any kind of a value. Okay, that's also very different, it's important to note, from having, let's say, an empty string like this, which still has a value, be it empty, or having a variable take on the value of 0. Okay, so two very different concepts, having a 0 or an empty value and having a nil value. Okay, so now let's get into optional variables, which actually look and function very similarly to regular non-optional type variables. But when we declare the type, we put a question mark after the name like this. Okay, so let's actually use, we'll run with that same example of the inventory item. Okay, so we'll have a variable, making it a variable, not a constant this time. It's going to be first item. Let's just call it first item shorthand. Okay, this is going to be an optional string this time. Okay, and note how if I don't assign a value, it takes on the value of nil. However, I do want it to have a value right now, which means that it's going to take on the value of food. So this is different, again, from a non-optional variable because it has a question mark. And this means that, again, I can assign it to be nil, okay, equals nil. So first item equals nil. But what I couldn't do is assign, let's say, name to be nil or number of lives to be nil because these are non-optional variables. Now, because this is optional and could take on the value of nil, just going to comment that out for now, this means when we're retrieving properties off it, we have to use some special syntax. Whereas with this string up here, which was non-optional, I could just call on my string name.count and retrieve the length of it. Well, for an optional string, I actually have to call the name, so first item.count again. But note how the compiler has actually put a question mark right after first item name. The question mark denotes the meaning that this could be nil. So if for whatever reason first item is nil, as if we assigned up here, okay, then we're going to store the value of nil and return that. So let's say I had a variable called length, and I set this equal to first item.count. This means that length is an optional integer because this could return the value of nil. So first item is nil, it returns nil, and if first item is not nil, then it's going to return, in this case, the value of 4. That also means, however, that length is of this type, optional integer. Now, if we wanted length to be a non-optional integer, there's a couple of things we could do. One is called force unwrapping, which I usually discourage, but I'm going to show you how to do it anyway because sometimes it's safe. Okay? And the second is going to use the nil coalescing operator, but I'll cover that towards the end. So let's talk about force unwrapping, and first of all, what is it, and second of all, why it's bad. So force unwrapping is basically taking an optional variable and forcing it to have a value, okay? We do so using the exclamation mark. So let's just say I had a constant, and I'm just going to call this item, okay, generic item, and I want to set this equal to my first item, okay? That means that this type is an optional string, as first item is an optional string. Now, if I want this to be a non-optional string, because I don't want to deal with optionals anymore, okay, I have to, again, force unwrap first item using this exclamation mark, and this basically reads that we're going to assume that first item has a value and then store it here. Now, this is problematic because if I do this, and set first item to be nil, this causes a fatal error and again would crash our application if it was indeed running. Okay, so that's why I usually discourage this. It's safe to use in situations when you know, for example, first item will have a value at that point in time. You can force unwrap it. Similarly, if we wanted the length to be a non-optional integer, so let's just call this item length. Okay, and I want this to be a definite int, I can force unwrap my first item dot count, okay, by enclosing it in brackets and then putting the exclamation mark there. All right. Oh, and actually that should be a type int. So this is again retrieving this value, but it's forcing it to have a value. If this returns nil, then again going to cause the app to crash. In this case, we're actually safe, and I'm actually just going to comment that right out. Okay, so the other way is using that nil coalescing operator, okay, which essentially looks something like this. So I'm going to do the same thing as we did above, but in a much safer way. I'm going to call this item length. Actually, I guess we'll just follow the same declaration as before. Item length is going to be, I'll give a definite type integer. This is basically going to be our first item, okay, dot count, okay, or it's going to be 0. So this is the nil coalescing operator, this double question mark. And this reads something like this. If first item dot count is nil, store the value of 0. If first item dot count is not nil, we'll store its value, which in this case is 4. Okay, so it's actually fairly straightforward. All right, so with the nil coalescing operator introduced, that's actually all I wanted to cover in this section, at least when it comes to optional variables. We will later on cover topics such as if-let and guard-let statements, which are, again, safer ways to check for a nil value. But we'll cover that in the control flow section. For now, I just wanted to introduce a concept, take a look at some syntax, and at least give you one safe way to check for nil values. Like I said, this is okay sometimes if you know this is not ever going to be nil, but if you think it might be, then you'll probably want to use other ways to check. With that being said, we'll just give a very quick wrap up. So optional variables look very similar to non-optional variables, but we declare them as optional with the question mark after the type, and this means they could take on the value of nil, whereas non-optional variables can never be nil. All right. Retrieving properties of optional variables requires the additional question mark, and this is called optional chaining. Okay, this is just a safe way to store the result in an optional variable, or could be storing the value of nil also. If we want to store the value that is not nil, so we definitely know it has a value, we can force unwrap it with this exclamation mark, or we can use this nil coalescing operator to store an alternative value if this works out to be nil. Okay, so basically, if first item is nil, so I uncommented this, then item length would just store the value of 0. Okay, so with that being said, we can now move on to the next section, which will be exploring some basic conversions that we can, or rather basic operations that we can perform between different variables that we've seen so far. Hi everyone. The focus of the previous two sections has been mostly on getting familiar with the kinds of values that variables can take on and kind of how to assign and reassign these values. So we covered the 6 basic and commonly used types up here in the first section, and the second section focused on the optional variables, which is basically an extension that can then take on the value of nil. So hopefully by now you've played around with them a bit and have become a bit more familiar with the different types and the range of values that they can hold. So now we're going to take a look at some of the things we can do by examining some basic operators and taking a look at a few examples of the operations we can perform using these different variable types. So we're going to break this down into several smaller categories. We'll first take a very quick look at the assignment operator, which is actually something we've already used. Then we'll take a look at some simple unary operators. After this, we'll focus on some arithmetic operators. Next comes some conditional and logic operators. We may split this into 2 parts, we'll see. And finally, we'll finish up with some ternary operators, of which there's actually only one, but it's going to be a fun one, so we'll save that to the end. So let's take a look at the assignment operator. Well, like I said, we've actually been using this all along. It's basically just a single equals sign. Now, this is very different from the double equals, which is actually used to test a condition. But basically, we use the assignment operator by putting the name of the variable on the left and the value we want on the right. And now we can assign a literal value, like with this number 3, or this value false, or this string value. Or we can assign the value of an existing and previously assigned variable, such as the case with is the door open and is door open. Okay, so the assignment operator is basically just a single equals, so no need to go over again how to use that. Now, for our unary operators, we have actually three of these. One is the not operator, one is the positive, and one is the negative operator. Now, these two are fairly straightforward. The positive just turns any numerical value positive, and the negative just negates any existing numerical value. So if we had something like, I'm just actually going to call this generic int, okay, and it's going to be an integer, obviously, and let's set this value to 5. I'm just going to take this and just paste up here for future use. Okay, so if we have this value now, and we wanted to use one of these operators, we could just create, let's just say, another variable. Actually, I'm going to make this a constant, and this variable is just going to be new int. Okay, this is essentially just the negative generic int. Okay, and this is just going to be a -5 in this case. Now we can do this with a literal value or with an existing variable value, and a positive will do exactly the same thing, but it will make the value positive instead of negative. In this case, that's already positive, so no changes there. Now, as for our not operator, well, this essentially makes a true value false and a false value true. So it kind of just reverses the value of a Boolean. For example, if we have the is the door open, we could then set is the door open to be equal to its not, or the not of its original value. So in our case up here, is the door open is true. Okay, that's where we ended it off last time. At this point, is the door open is now equal to false because we're taking its existing value and negating it. And as you can see, false right there. The reverse would be true if this was false to start off with, and we set it to not that, then it would just become true. So the unary operators always go right in front of the variable or the value we want to apply them to. Now, let's move on to our arithmetic operators, seeing as we finished covering this. And there's actually quite a few of these, and there's quite a few variations among all of these arithmetic operators. So we'll have all the basic ones, we'll have addition, subtraction, multiplication, and division, but we'll also have stuff like the modulus operator, and then we can have any combination of these. So I'll add on something like an arithmetic extension, let's just say, extension here. Okay, and these are going to be a combination of the assignment and the arithmetic operators. These are going to be your plus equals, your minus equals, your multiply equals, and your divide equals. And I'll cover these in just a second. Let's just take a look at the basics. So the use of these is fairly straightforward. Typically, we'll have some value on the left, so we could say something like new int is equal to generic int plus 5. Okay, in this case, this is a simple addition operator. We're just taking the existing value here, adding a 5 to it, and then storing the results here. And the multiplication, subtraction, and division work in exactly the same way. We can put in any combination of literal values or of variables we want. So we could have this be another variable. We could have them both be literal values, and we can actually keep this chain up. So we could do -2 plus perhaps the existing value of new int, and so on and so forth. Just keep in mind that order of operations will be observed, so any multiplication or division will occur before the addition or subtraction, unless of course you put stuff in brackets like this, and it's always encouraged to do so just to communicate your intent a little clearer. Now, something that might be new to you who haven't really programmed much before is going to be this modulus operator, and this basically divides two numbers and then returns the remainder. So let's create some result called remainder, and this, we can set this equal to, actually just going to set this equal to generic int modulus 2, and this should basically return 1 because it's going to take our existing value of generic int, it's going to divide it by 2 and return the remainder, which in this case would be 1, seeing as 5 divided by 2 leaves 1 as its remainder. Now, one other thing that we can do with the plus operator is actually append strings. This is taking one string and sticking it onto the end of another. So if I had something like, let's say mammoth string is equal to mammoth here, I'm just going to add the space there, and then we had, let's say we could actually have an interactive string as well. Okay, this is going to be equal to interactive. Then what I could do is I could say something like let mammoth interactive string, okay, be of type string, and I could set this equal to mammoth string plus interactive string, and it's basically just going to take this value and stick this value onto the end, so that here, as you can see, I get mammoth interactive. So those are your basic arithmetic operators. Now if we take a quick look at the extension, these are just going one step further. This is basically just going to take a variable's value, it's going to perform this operation, and then it's going to extend that onto that variable's value. Now that might be kind of confusing wording, so let's just take a look at this example here. So I'm just going to set new int, okay, back, oh actually I already have it declared up there, new int is just going to be back to, let's say, 10. All right. Now, if I want to multiply new int by 2 and then store the results back in here, so I don't want to store the results in a new variable, I want to change the results and then store them back in here, I could say something like new int multiply equals 2. And what this is going to do is it's going to take the existing value here, it's going to multiply it by 2 and then store it back. So we can kind of think of this as being the same as new int equals the existing value of new int, whatever value it currently holds, times 2. All right. So not completely necessary to use these, it's just kind of shorthand form of this. So it's very convenient. And the other 3 operators work in exactly the same way. Alright, so let's move on to some of our conditional and logical operators. Now, some of these we'll actually cover in greater detail in our control flow section. And so I'm just going to mention my logical operators, but won't really cover them in greater detail. Actually, let's just take this and put them in their own section. Okay, so my conditional operators are going to be those that test some kind of condition, typically of some value relative to another, and then usually return true or false based on the results of that test. So there's quite a few of these, and most of them you should be fairly familiar with. So we'll start with stuff like the greater than or equal to, less than or equal to. We can actually have the is equal to. We have the is not equal to, and then there's a couple of additional ones. So this tests the membership to a particular class, and this one, but we probably won't really cover these in great detail. I don't often end up using them. So I'm sure you've all seen stuff like this. This is just testing to see, we put this between 2 values, and then again it returns a true or false based on the results of that test. So let's say I created some Boolean variables to hold the results of some of these tests. I could have a Boolean called something like is greater than, okay? It's going to be a Boolean or a bool, and we could set this equal to, for example, something like 5 greater than 2. All right, so in this case, this is going to test this condition. It's going to return true because obviously 5 is greater than 2, and it's going to store the results of true inside of this Boolean variable. It works in exactly the same way with something like greater than or equal to. If we had less than, it would store the results of false, and so on and so forth. So fairly straightforward. So far with the operators, the assignment goes between the name and the value. The unary goes before the value we want to change. The arithmetic operators go between either 2 numbers or 2 literals, or a combination of variables and literals. The arithmetic extension ones go, they have the name of the variable on the left and then the value we want to change to on the right. And our conditional operators have 2 numbers, or again any combination of variables and literal values, and then the assignment on the left here. So we'll have the assignment, the variable name, the assignment, and then the test we want to perform. So these are the basics of your conditional operators. I'll just quickly go over the equals and not equals. So we could have something like is equal to, again, another Boolean value. And this is just going to be something like 5 not equal to 3. All right, so this is going to be true in this particular case because 5 is indeed not equal to 3, so it's going to store the results of true. The name is a little counterintuitive, so this should be something like this. This tests the actual equal of the value, so that's the double equal sign there. Now, I'll point out that I know in some languages, particularly Java, if we're testing string values, we actually use the string name .isEqual, okay, and then the value in the brackets. Well, in Swift 4, luckily for us, we can actually use this operator to test string values as well. So it's literally just testing to see, is this value the same as this? Returns true if it is, and returns false if it isn't. Otherwise, the rest of these work in pretty much the same way. These ones we won't worry about. I just wanted to bring them to light briefly. Okay, so on to our logical operators. So we use the not operator in some logical operations, as well as the and operator and the or operator. Okay. Additionally, you'll see something like this, just a single vertical line, but we won't be covering that. We'll only bring that up in its specific use cases. So these logical operators are used generally to test some kind of a condition. So again, we'll test a condition and return true or false. Because the use of these won't necessarily be clear without some control flow, I'm actually going to bring these up and explore these in great detail in the control flow sections, particularly when coupling stuff like if statements. But basically, this is a way to test to see if multiple conditions are true, and this is a way to test to see if either or multiple conditions are true. All right. And then we've seen the not operator. That's just a way, when we're using it in a logical sense, to test to see if a value is true or false. Okay, so finally onto our ternary operator. So we just have the one, and this looks a little like this. So we'll have our value equals, okay? Then we'll have a condition to test, okay? And then we'll have something like this. If that condition is true, we'll do this. And if that condition is false, we will do this here. Oh, and my syntax is a little off. I just want something like this. So we basically read this as, we'll have some value here. We're setting this equal to, we test this condition, which is typically a true or false result. If that condition is true, we execute this code. And if that condition is false, we store this result or execute this code. So an example of this might be something like this. So first of all, actually consider the case of our door being open again. So is door open in this case is false, and I'm fine to keep it that way. But we're basically going to test that value and then print out some kind of a message depending on whether or not it is whether or not that door is open or not. So we can have something like message, okay, be a string, and we're going to set this equal to is door open. All right. If this is true, then we'll print out the message something like door is open. Okay, and if it's false, we can store the results of door is closed. So again, this reads like this. We'll test to see if door is open. If door is open, so this is true, then we'll store this result. So message equals door is open. And if is door open is false, then we'll store this result. Door is closed in this case is being printed out. And that's because is door open is indeed false. So our test fails, and we store this result in message. Okay, so that is the only ternary operator that we have, and it looks a little more complicated than it actually is. Once we start getting a bit more familiar with this, we'll find it's actually a huge way to save a lot of time over the long run. But with that being said, that is pretty much all of your basic operators. There are in fact more operators to cover, particularly those with regards to bits and kind of shifting left and right and stuff, but that's beyond the scope of our basics of Swift 4. So I'll leave that up to you to either read up on, or we'll do sections in our massive Swift 4 iOS course. So you can look into that course if you are interested in learning a bit more about it. But otherwise, just going to quickly sum up what we covered in this section. This was just based on operators. We have just the one assignment operator, that's the equals. Unary operators here, again, go before the value we're trying to change, and basically just change the value of that particular variable or literal value. The arithmetic operators go between two numbers, so be those literal values, or they could be variable values, and so on and so forth. The arithmetic extensions are kind of a combination of the arithmetic and the unary operators. Condition testing operators go again between two numbers or between two conditions or something like this, and then return either true or false based on the results of that test. The logical operators, this is the not, the and the or operator. We'll cover these in greater detail later on. And finally, we just had the one ternary operator. It's just a way to test a condition and provide an alternative case based on that true or false value. All right, with the conclusion of our operator section, we just have one more quick variables topic to cover. That's going to be the topic of tuples, which is an excellent introduction in the Swift programming language that is not available in a lot of our other programming languages. So we'll move on to that. Once we finish covering tuples, we can move on to our next major topic, which is going to be control flow.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only do we get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy it before the sale ends. Thanks for watching, and I'll see you in another video.